All right, this is Orlando Solis for Advanced Quantitative Reasoning. Okay, guys, here's the thing. I'm going to go ahead and show you how to use the this calculator's functionalities to do linear regressions and how to graph this piecewise function. So you can see that there's pieces right here. There's a piece of one function right here, another one, and two more right there. So there's a total of 5 pieces to this. So we have this thing right here. We're going to fill this out. We're going to go ahead and find out the slope and the equation of the line, domain, and range. And you know what? It's going to pull some really easy stuff that we used to do, like the fact that we can get the equation for line A and just go ahead and just say, all right, we got 2 points right here. We're starting right here and going down. Well, let's see. The slope of this line is 1, 2, 3, 4 units down, and then 1, 2, 3 units to the right. So the slope is -4 divided by 3, and the slope intercept, which is B, is 7. So if I were to go ahead and graph this, this would be y is equal to -4/3 x plus 7. And so that would be the equation for the line. But also we have something else called domain restriction. And so what that means that we're going to go ahead and tell the calculator that you're only going to draw this line from where x is equal to 0 all the way up to 3. Those are the only areas and we're going to use an inequality for that. So this is just how to go ahead and first get the line and all that. So first off, we're going to go ahead and do a linear regression. So we're going to grab this guy. This is the Excel kind of looking thing. I'm going to go ahead and just show you again. This is the Excel. I'm going to click on that. I'm going to name this column X, and then I'm going to name this column Y. Why? Because I can. And all I need is 2 points. So the first point that I'm going to use is 0, 7. So x is equal to 0, y is equal to 7. And then I'm going to use the next coordinate, or this point right here, which is 3, 3. So x is equal to 3 and y is equal to 3. And so now these are the coordinates. These are 2 ordered pairs. Now I'm going to hit on. The easiest way for me to do it is to go ahead and use the calculator itself. Although we can use the this actual Excel file to go ahead and do it. I just don't like the way it looks. It's just too small. So I'm going to go ahead and use this. Never use this calculate. I'm going to use this calculator little gray button that we have right here. So I hit menu, and I want this done in statistics. This is going to be on stat calculations, and this is going to be linear regression, mx plus b. So of course that's our normal thing. So just to show you that, it's just menu 611, or no, not 611, but menu 613. And so it's going to ask you for your X list, and we have that. We went ahead and named those lists. That's what those were. And this is Y. And so now we're just going to hit OK. And so boom, there's our equation. Our M is -1.3 repeating, and that's going to be -4/3. B is 7, which we have, and so that's about it right there. So just to go ahead and show you that M is negative whatever, we can use what we call, let's see, negative, this is negate, 1.3 repeating. We're going to just put a whole bunch of 3s, no 6s. You have to put in a lot of 3s in order for the calculator to do the estimation to a fraction correctly. So number approximate to fraction, just say that, just say OK, and it says -4/3. If you know your fractions, you should be able to do that, no problem. So that's all of them right there. So they have different slopes. As you can see, I've already done them here. I have all the equations right here. This is the first equation, second, third, fourth, fifth. Then we have our things right here. These are domain restrictions. So as you can see, the first domain for the first line goes from 0 to 3. The next one goes from 3 to 6, 6 to 9, 9 to 15, and then 15 to 20. So as you can see right there from our domain restrictions. And so that we're going to end up with this graph. So let me show you how to graph that next. So I'm going to hit on. I want to go ahead and get the graph. Oh, wait a minute. I'm going to go ahead and just use a new document. So we're going to go to graphs. Then we're going to go ahead and push this button right here. You know, there's our button. And it brings up this menu, and it brings up all sorts of things, absolute value, a whole bunch of different things. But if we're interested in this particular button right here, which has the bracket with 3 squares and then another 3 squares, this will give us a piecewise function. You can even see that it looks piecewise from its create piecewise function. So we have a total of 5 functions. Say OK. So on the first line, we're going to put this equation, not the y. We don't need y because basically f1 sub x is our y. So now we're going to go ahead and just start that. So this is going to be negative 4/3, and then that's x plus 7. Then we put in our domain restriction. So our domain restriction is from 0 less than or equal to x less than or equal to 3. So 0 less than or equal to x less than or equal to 3. Now, this is the way I would go ahead and run with this. For the next line, we're going to put in our next formula, which is going to be negative 1/3. So negative 1 divided by 3, and that's going to be x. I know I can do this on the keyboard a lot faster, but you know, we like to go ahead and be thorough. So now we're going to put the domain restriction for that one, and it's this one from 3 to 6. And if you notice, this just says less than. Since we have a less than or equal to on this part of the domain restriction, this one has to be just less than because they cannot be the same thing at the same time in order for this to be a function. It's a technicality, but you know what? I think it's necessary to understand that in any function, we need to make sure that we can't have two y's occurring at the same point. Otherwise, we have an error. It's a technical issue, but you know, it's one that I think is very important. Okay, so there it is right now. So that's it for those two. I'm going to hit pause, and then this is going to actually all be done. Okay, and we're back. All the equations have been inputted. I hit enter, and here it is. I mean, it's a little off. I can't really see the whole thing, but you know what? I can fix that by using our menu and going to our window and go to Windows settings. We're going to be changing the Windows settings, and there's a reason why I'm scrolling back up, because I'm going to use this as our window. So from X, we start at 0 and we go up to 20. So I'm going to go ahead and start this from 0. Actually, I'm going to start this at, well, I'm going to start at 0, and then I'm going to go all the way up to 20. The X scale stays at auto. I don't need to worry about it. And then I need to look at my Y. It starts at 0 and goes up to 8. So I'm going to go one more than that since it shows it's a little bit more. I'm going to go all the way up to 9. And then I hit enter. Okay. And there it is. Now, this is showing our piecewise function, and it's a little bit in the way, so I'm going to move that. But as you can see, here's our function. And it matches our picture over here. So we have this all. So there you go. That's how you can go ahead and grab piecewise functions on the TI Nspire. It's a little bit easier than the TI-84, and I would suggest you get used to it. As you know, we all get used to these things. Ooh, tired. Okay, so have a nice day.